Testing, testing. 1, 2, 1, 2. Looking for some audio now. Testing, testing. 1, 2, 1, 2. Looking for some audio now. All right, I think we are live and connected. We have a stream going. Audio sounds like it's good to go. I'm going to have to turn off. Testing, testing. 1, 2, 1, 2. Feedback here. I want to be hearing myself in an endless loop. All right, thanks everybody for joining. This is a live stream. We're going to be talking about Adafruit's line of boards that support CircuitPython. I have a number of examples to show here tonight, today / tonight. We'll be covering products like the Trinket, the Circuit Playground Express, Circuit Playground Bluefruit, the Adafruit Clue, the Monster Mask. I also have a Qriket here that I have paired with the Circuit Playground Express. It's driving in RGB right now, an RGB LED. And so I'll just kind of go through these, talk about the products at a high level, what the offering is out there, some tools that I use, the workflow to work with these devices, and just kind of show how simple and accessible they really are, and how you can probably use them in your next project if you needed to, fairly simply and quickly to prototype things out. And let me just quickly check Discord here to see, I'll make sure I'm not missing any kind of major messages. Okay, so I'm getting some feedback to increase the size of the downward camera. That's a great point. Sorry. Let's see if this will help. All right, the down-facing camera isn't of the best resolution, so you'll get a sense of what's down here, but not necessarily a lot of detail. But I could maybe tweak with that. Yeah, okay. Let's see, what else can I show here? So I'm going to also be using some tools like Moo, Make Code, and a couple of others that I want to demonstrate. So I want to actually kind of just see if I can get those to show up. So give me just a moment. Yeah, no problem. Thank you, Niall. Niall's just giving me some feedback to try to tweak things out around a little bit so we can have the best presentation possible. So Niall's from HackerLab, and thank you, Niall, for that help. I am going to minimize that window now, and I have a version of Moo up and running. So let's see if I can get this to recognize on the broadcast here. And it won't let me. Okay. Oh, there's Moo. Yay. Got it. So I'm going to move this over to the side. I'm going to try to manage this a little bit better. All right, I might move them around as necessary. And you don't need to look at my mug the whole time, but we'll try to make room for everybody. All right, so Circuit Playground on CircuitPython, what is it? CircuitPython is embedded fork of Micropython that is specifically for microcontrollers. It runs on device. It's as simple as editing a text file, .py text file. It should be a Python, MicroPython, CircuitPython formatted file. And just quick text file, you make some edits, you save it to the device. Once the device saves it, it refreshes itself and starts to execute the program on chip. So it's interpreted and executes on chip. This allows you to do some pretty rapid prototyping. I am not an accomplished programmer. I am not, I don't have a degree in programming. I am more a DIY maker. So I come at this from the perspective of accessibility and non-tech kind of perspective. I do work in tech industry and I understand tech. I just am not a professional programmer. So I just can't claim that, and my skills will clearly show that. But what's great about these devices, it allows someone like myself, who's not a professional programmer, who dabbled at best, to actually get in and start writing code and see lights blink, see things happen, make engines turn, make servos actuate, just with a little tiny bit of code and a little bit of understanding. So that's kind of what is great about these devices. They give you access to the world of programming without having to be a heavy-duty programmer. And then you can see and touch and feel the results of your programming in real time on the device. So that's what's one of the really fun things about it. And I guess one of the more approachable things about physical computing as opposed to more, esoteric computing. There's a couple of tools that I've come to use. Now, you can use a number of these Adafruit devices with makecode.com, and I'll share that with you now. That's makecode, makecode.com. It is a Microsoft-sponsored effort to allow folks to get involved with programming through a block programming interface. And I'll just quickly open that up, hopefully. And let's make sure that OBS can see it. All right. And I'll get rid of this. Sorry, I'm not the most accomplished at OBS here. I've used it a little bit, but that's why we do sessions like this, to get more familiar with it. So this is makecode.com. You can see there's a number of devices that allows you to choose from here. The microbit you may be familiar with. It's another similar type of microcontroller that is in the same form factor as the Qlu, the Adafruit Qlu. Adafruit Qlu actually copied their form factor. I don't know if copy is the right word, but based their form factor off of the microbit form factor, so it can fit the same peripherals and devices and has similar pinouts. So your projects can be semi-transportable between the two if you decide to do so. This middle choice is the Circuit Playground Express, and that is this device right here. I currently have it driving this LED display, and it's simply hooked up to a battery, the Python code that's on the device, and the actual display, and that's all that's running to have this rainbow effect running in the background. And then there are a number of other devices. There's a Lego, Mindstorms NXT. You can do actual mods in Minecraft with this block-based programming tool, but we're going to be focused on the Circuit Playground Express today. So we just click that. And this is not CircuitPython, but I just wanted to kind of lead in with this because this is a great tool that if you have kids or folks who haven't programmed before that want to start to get introduced into the concepts of programming, and they want to mess around with the Circuit Playground, then you got a kind of a nexus of both these things here that nicely dovetail together. This is the interface as it loads, and we have a number of types of logic blocks that we can piece together to make our device do whatever it is we want it to do. There is a simulator in the web browser that you can actually, even if you don't own a Circuit Playground Express, you can go ahead and engage in the creation of programs and seeing how they affect your device here with this simulator. Simulator allows you to stop, this button here allows you to stop the simulation. You can step through, you can kind of refresh, you can turn audio off and on, and a couple of different features there. Just to kind of show a really simple type of program, we have a forever loop. So if we wanted to drive NeoPixels, like you see the kinds of NeoPixel displays that I'm driving here, you might just add something simple like show ring. This will create a lighting effect, oops, across the 10 NeoPixel LEDs that are on device here. And we can actually simulate this out. So when I put this into the forever loop, and these are all red, you can see that the simulation over here has red lights. This is just a quick example of how the block-based programming will allow you to kind of get started with programming concepts, but not necessarily have to know all the syntax and all of the idiosyncrasies of how to display that or how to format that syntax. You can just kind of deal with the actual concepts. Number of light things, set brightness, set pixel color, show animations. So if we did this instead of this, we can just kind of drag this over here to get rid of it. And now our simulation will reload, and you'll see that there's a rainbow animation showing on the simulation. And that's, if we were to load this onto the device, excuse me, that's how the device would behave. So that's makecode.com. That's just, I've been using that as an entry point to kind of talk about some of the more advanced tools that are out there. And if you are familiar with it, you could actually put in maker.makecode.com up here in this URL. And that kind of takes you from the simple block-based kind of interface to a more advanced, a more wide array of board support and a more advanced block system to support those different boards. So here you'll see there's an Adafruit selection at the top. There's project selection, much like we had in MakeCode. So once I clicked Circuit Playground, it kind of loaded this interface, and it says, oh, my projects, what do you want to do? And so I can kind of start a project here, or I can load up an old project. It also gives you a bunch of samples for things to kind of try on your own if you need a little bit of a kickstart. But again, the similarities in the interfaces here, you have this My Projects bar. So if we go to MakeCode, again, we have the My Projects bar right at the top, but then we have a number of devices it supports. So if you scroll down through, Adafruit is the first category of devices, but then we have Arduino, SparkFun, ZenoBox, Digital I/O. Oh, sorry, those are actual projects. So yeah, so there's a number of boards is the point there. We can scroll through these boards. You can see the Trinket is here, Adafruit Gemma, Circuit Playground Bluefruit, which is a Bluetooth LE version of the Circuit Playground, and a number of other devices. They're all some are very similar in framework or hardware, and there are certain groups of them. The Arduino stuff tends to be one set of kind of processors. The Bluefruit stuff tends to be another set of processors, the NRF 52840. So some of these kind of categories of families exist on the devices, but these are all from Adafruit. So in the case of Trinket, here's a Trinket M0. I can select that. I can say I want to do a new project. Give it a second here. All right, so what's cool about the makercode.makecode.com website is it will actually, if you have samples that other people have developed, it'll actually give you wiring diagrams for how you should wire it up. But here's the Trinket, and I want to just kind of have to browse away from this for a second. Oh, were you guys not seeing all that? Were you not seeing that? All right, let me see here. Let me go back to that. Oh yeah, you were, good. All right, so this is a Trinket M0. It's not a huge device, and I meant to have something I could put it against scale. This is a AAA battery, not huge. And so there's the Trinket right next to it. Not a big device. This has an ATSAM D21, I believe it is. Maybe 50. But it's an ATSAM processor, which is like 6 times as fast as Arduino, has 4 times the memory, and again, it works with CircuitPython it also works with Arduino IDE. And all these devices, by the way, they work with Arduino IDE. They work with the CircuitPython programming language, but they also work with the MakeCode block program. Well, not all of them, but a number of these devices also work with MakeCode. So you have a lot of ways to get access to program these devices that you're not kind of set into one style of programming. If you're comfortable with Arduino IDE and C, then you can go ahead and program in that style. If you're more comfortable in Micropython and using something like Mu or some other editor, then you're allowed to do that. And if you want to just do basic block programming, you can do that as well. So they're very accessible as far as the types of programming language that you choose and just the ease of accessibility. All right, so these things are tiny. The Trinkets are tiny. And so let me just kind of do a roll call. So this is Trinket, pretty small. Probably the next thing up size-wise that I have is the Clue. And that's probably a matter of opinion, but which is not a huge device. This device is cool because it has a, oh, come on now. Thought it did. Battery's going dead midstream here. That's not good. So give me just a second to do a quick battery swap. There we go. So this Clue has a screen on it. It has an accelerometer. It has a gyroscope. So here we have kind of a digital Plumb Bob. So you can tell if I tilt it in one direction, it goes off. If I tilt it in another direction, it comes off center. And if I try to hold it perfectly flat and plumb, then it gives me that measurement. So this device, again, very small, has the microbit form factor with the edge connector. It has a number of different sensors on this, and this is a great example. So we have temperature sensor. Let's see here, sorry. Temperature sensor, I know it's not the best. Let me get those lights off. Pressure sensor. Humidity sensor. I don't know if you can barely see the line being drawn there. What is this? Light sensor. So if I put it in and out of the light, you can see the different waveform that's being generated there. This is a pulse sensor, so the lights are turning on for me to put my finger on it, and it's actually going to try to measure my pulse, but I haven't had a lot of great luck with that. There's a proximity sensor. Oh, this is the pulse sensor, actually, sorry. The other one was a color sensor. It uses those lights to sense colors. And so, yeah, this device is packed: a microphone, accelerometer, gyroscope, magnetometer. So this device is packed full of all kinds of sensors. And the other great thing about these Adafruit devices is they're no solder. Right? You don't have to breadboard. You don't have to solder. You don't have to make any kind of external connections. They're all embedded on the board, which is great. It's a great, and it truly is like a playground, right? They call it a circuit playground. And it's truly a playground of different sensors and devices and lights that you can actuate and kind of get access to. So that's kind of cool. So that is the Clue. That's that squarish kind of device. So then we have the Circuit Playground proper, or excuse me, Circuit Playground Express. This is an ATSAM-D21 processor. So this is, again, faster, or orders of magnitude faster. Well, I don't know if orders of magnitude, but several times faster than Arduino. Several times the available storage. They act like USB drives when you plug them in, so they're visible through any computer, pretty much any computer. They show up as a text file on a small micro drive. So when you just edit that text file, it instantly kind of resets itself and kind of consumes that file and starts running it. And so it's a great step up from the Circuit Playground, which was their original device. That was, I believe, an Arduino-based device. So then they created this ARM-based device. And then they moved on to the Circuit Playground Bluefruit, which is the NRF 52840. This is a Bluetooth LE device, same form factor as the Circuit Playground, the Circuit Playground Express. Let's see, did I get that wrong? Yeah, there we go. But it has a Bluetooth radio. And so you can communicate between devices with this particular version. This Circuit Playground Express has an infrared. blaster and receiver on it, so they can communicate with other devices as well with the infrared blaster. But this has the Bluetooth radio, so this is a little bit more, not line of sight, not dependent upon any kind of blockages between the data stream. You can kind of just transmit information. It also allows you to do like a Bluetooth beacon, and I believe it allows you to do Bluetooth mesh as well, like where you can kind of receive and then broadcast. But I'm not super up to date on the Bluetooth stuff. So that's that. Over here in the corner here, I have the Monster Mask, which can run CircuitPython, but for the eyes that come embedded with this, and I don't think I actually had a chance to recharge this battery, there's kind of an eye movement that happens on both of these eye displays, and that is not running in CircuitPython. My understanding that's the compiled code because it needs to run so quickly when the eyes shift and the irises kind of open and close, and dilate, and the kind of squint a little bit. All that happens so quickly that Python might not be the fastest way or the right way to do that. So I believe that is compiled code. When you see those eyes working, I don't have a working version right this second, but I might in a moment. And then the other item that I wanted to show was this daughter board for the Circuit Playground Express and or the Bluefruit. This is basically called the Qriket, and this board allows you to piggyback a Circuit Playground device on top, but it's actually kind of just connected via some risers, some brass risers that connected to the various points on the board that have actual real meaning, real connections that allow it to communicate with the Qriket. And the goal of the Qriket was to allow you to use your Circuit Playground Express more in the robotics realm. So the driving of solenoids or motors, or the controlling of servos, these types of things that require more power than your Circuit Playground will be able to handle, because these are kind of low power devices. The traces aren't super thick on these. When you look at them, they are not intended to carry a lot of electricity. So this daughter board here allows you to see, I have a separate power supply plugged into it, and allows you to do things like drive a high power LED, right? This is going to be like a 3 to 8 watt range. Something that typically you would not be able to drive with the Circuit Playground board by itself. All right, so that is the Clue. That's the Monster Mask. That's the Circuit Playground Express. We also have the Circuit Playground Bluefruit and the daughter board, the Qriket daughter board, that allows you to kind of do more robotic centric activities. Cool. Okay. So let me then kind of get back in. Oops, sorry. Let me kind of go back to our tool. And the other great thing about block-based programming, and excuse me while I just get a drink of water, is that you can't, they don't just support blocks anymore. There's functionality that lets you kind of swap between the block programming interface and an actual syntax-based programming interface. And so what I'd like to show, oops, sorry. What I'd like to show is how that works in reality. So I showed you before, we have a forever loop. We can drop some lights into that. So let's just kind of do the same thing we did before. This device does not have lights directly on it, so we can't see it. But what it's showing us is if we were to hook this to an RGB, to a NeoPixel, well, actually, how does it have this one hooked up here? I believe this is probably an RGB kind of treatment. So it shows actually 4 wires, an RG and a B, and then some type of ground wire, perhaps. 3 volts. Oh, there it is. Ground and 2 signal wires, it looks like. So you can see that it actually makes the connections here for us, and then you can kind of see where the wires lead up to these top connectors up here. So that's one other really cool thing about maker.makecode.com. If someone's built it or it has it in its database, it will show you the wiring diagram for whatever device you're working with, which is kind of really cool. as a jump start mechanism. But back to my main point was, once we have something that is working, so let's say this were a NeoPixel strand that has a rainbow color pattern that is playing in the background, I can then go into a JavaScript mode and say, what does that look like in JavaScript? And actually see the syntax that was created by my blocks. And the cooler thing is, even cooler, that more recently they've allowed us now to kind of even venture into Python, which is an even, well, for myself, an easier language to understand, and what I've tried primarily have been working within, so I can then see the actual syntax for Python code as it relates to these devices. Now, this isn't Micropython, this isn't CircuitPython, this is real Python, is my understanding. So there's still a little gap there that it doesn't fully close, but that's just a kind of a cool way to kind of get started. Let me just quickly check Discord, make sure I'm not ignoring anybody's please, requests, or desires. Okay, looks like we're good. And I'm just going to check our Hacker Lab channel. And I don't see any questions or chatter there, so okay. All right, so the next up, what I'd like to show is another tool, and this tool is called Edublox. So let me just make sure that it's broadcasting. Okay, excellent. And this is found at edublox.org. This is pretty cool because this is a block-based programmer. It allows you to swap between blocks and code, so you can see syntax related to blocks. But what's cool about this is MicroPython. This is straight up, you can take the code out of this and dump it into one of your MicroPython devices, and it'll work as is out of the gate. So to get a good kickstart, if you're looking to do a MicroPython project, you can come to edublox.org, select the MicroPython selection, and let me actually just back out just so you can see. You would choose the, excuse me, I said MicroPython, it's the CircuitPython selection. It shows a Circuit Playground Express, but it's not exclusive to that. So then you get into the block programming language. Here's what sometimes that you need to do, and it's not super clear, but you do need to import some libraries to make some functionality work. There are a number of libraries, excuse me, that are included with the CircuitPython core, but there are some libraries that you do have to pull in. So what I do for my own purposes is I go over here to samples, and I can say, okay, I want a NeoPixel sample, so NeoPixel demo. All right, so then it puts in a number of blocks for me that someone's already kind of crafted to help me understand how NeoPixels work. And I can look at the blocks, but then I can also just say, well, show me the code. And there's this code right here. I can take this import board, import time, import NeoPixel, the setting of this MP variable, the implementation of this while true do loop, and the number of things in this loop. I can just take this all, right, just like this, oops, copy it. And I think I have the Trinket plugged in right now. So I can just take the code that I copied. I can go over here to my File Explorer. And I've already plugged the Trinket in before I started even broadcasting. So we should see it. Here it is. It's in my File Explorer drives list. It's named CircuitPy. I click on it. I can see the files within the CircuitPython directory. There's a library folder. Looks like I've added a couple libraries already. I was experimenting with something. And then there's a couple of assorted, support folders, and then there's the main.py. This is the actual program that I want to modify to then have the device, this Trinket right here, execute a new code set, if you will, or a new set of commands, I guess is what I'm trying to say. So that is CircuitPython. It's eDrive, and the name is main.py. So I just head over to Moo. This is my Moo editor. This is the kind of the newbie prescribed editor for CircuitPython. It allows you, it's very CircuitPython friendly. These devices have some requirements insofar as how the files are closed and saved when they're actually closed and you're done editing them. Some editors like WordPad and Notepad and other editors of almost any ilk will have issues with not fully closing the file or the device not recognizing that the file is fully closed when it's closed. So Moo does a good job of closing the file and with the device recognizing that the file is actually closed and saves it properly and doesn't have corruption issues. So you can download Moo, it's free. And hopefully, I'm getting a lot of beeps here. Hopefully, maybe can you not see Moo? Checking. Oh yes, okay, can't see Moo. So let me, yeah, my OBS newbiness here is showing. And I did restart Moo, but for some reason, it is not letting me like that. All right. I just have to restart Moo here and see if I can get this thing to behave. So give me just a moment. Sorry, I know we got some blank screen space there. And good thing I got Niall yelling at me, telling me. Takes a moment for Moo to start. And it is up and running. All right. So I'm going to take the code I copied out of, I hope you saw this, out of the edublox.org website. I'm going to just replace the hello world syntax that's here. Or it's write your code here. Sometimes it says hello world. And I'm going to just paste that in. Okay, now I'm going to save this, and it's actually going to save this file again to this main.py file. It's going to save it to my CircuitPython device, which is this Trinket that's currently plugged in. So when I hit save, what will happen is you'll probably see this light blink, and it will kind of reconsume the new program. And then you see the light change, red, now it's blinking blue, and it's green, and it doesn't like, it is having an error. So those color sequences are actually telling you that the device is in error. So let's see, maybe I didn't import one of my libraries that I needed. Import board, import time, import NeoPixel. So if I go to the device, I'm hoping that you can, let's see here. That doesn't look right. Well, I'm going to browse the file folder. You may not be able to see this, and in the library, I have NeoPixel, but I don't have the other two things I'm importing, board and time. I think board comes for free, but I think time I have to put in here. So give me just a second and I will browse to get that. And you know what, maybe I will just for sake of ease here, go back to Edublox. Sorry, I'm still working in here. Done. Okay, well, kind of stuck right there. I'm sorry, you'll have to look at Moo while I do this with another part of the screen here. because we didn't do it right. Okay. Let's try this. We'll do this one. Won't be so bad. All right, I'm going to try some new code here that doesn't try to utilize as many libraries. See what happens. I hit save. And it's still kind of erroring out. And I'm kind of thinking it's because of libraries, but because of my screen setup right now, it's going to be difficult for me to resolve that. So maybe when I get a chance a little bit later, I can go back in and fix that. But the point is that you can use edublox.org to use their block interface to get programming and their samples, their canned samples that they already have available, to set the blocks in place for you. Then you swap over to the Python code, then you get the code that it gives you, and you can drop that right in, drag and drop that, or paste it right into the file that's on your CircuitPython device, and it will reboot itself and restart and actually execute that code. With the exception that you have to have the right libraries in place. So you'll have to make sure that that's the case. But it's that simple. You literally make a couple edits in a text editor, you save the file, the device consumes it, resets itself, and starts running. You can do this with any device that will have a USB port and a text editor. So if it was a Chromebook, if it was even a handheld phone or Android device or what have you that allows you to actually manipulate something across a USB, that would be allowed. And obviously any kind of PC or Macintosh would allow you to make these kinds of changes as well. But you don't have to have a running computer with any type of processor. It's just really for the text editor is all you're angling for. So again, makecode.com, maker.makecode.com for more advanced Python, JavaScript, and block editing aspects of it. Also supporting more devices and more advanced devices. And then edublox.org to actually work in the CircuitPython syntax and block system if you chose to do so. And you can actually use their samples on edublox.org to kind of kickstart your programming by utilizing what they have, and then start to kind of reverse engineer and pick apart and tweak with what they've got till you can start making things, making it happen just a little bit differently, or change the colors, or stop the colors from changing, or whatever you want to do. You can then start to kind of tweak with the code and see how that works. And that's the great experimentation aspect of these devices. They let you just kind of go crazy like that. All right. To load CircuitPython on these devices, you actually have to download the proper CircuitPython. And I know we have black screen here, so now I'm going to see if I can show our browser. All right, there's our browser. And all right, so if you go to Adafruit.com and you click on the Learn tab, Adafruit obviously is the company that sells all of these devices. They have a ton more of them. They're for almost any application, whether it's prop making or internet connectivity, or communication, Internet of Things, smart home. They have devices that will basically serve most any purpose that you could think of. And then probably a little bit more. They're big on prop making in Halloween. So this was big. These monster eyes were big last year. Again, they have these kind of glowing eyes that you can put on a shelf or anywhere in the background, and just they kind of watch you and kind of are alive. It's that kind of fun stuff that really got me into electronics, and why I continue to enjoy it. So this is the kind of things that these devices give you access to. Kind of going back to the Qriket, and since we're talking a little bit about kind of oh, that was not good. I shorted out a wire there. This kind of board, the Qriket board, would be great for any kind of animatronics. If you're doing a Halloween, you want to make a ghoul that came up out of the ground, or something that made noise as you approached it or whatever. This is the kind of board that you would use to host your audio, to amplify your audio that you want to blast out, and to move the servos of the arms of the creature, and to light up the light of the eyes of the creature, what have you. This is the kind of board that would make that possible. This is the brain, and this would be the brawn, kind of really in that regard. And I'm pointing to the Circuit Playground Express and the Qriket. You do have to load CircuitPython on these devices. They kind of the output of the makecode.com website is a UF2 file. It's a binary file that you kind of drag and drop onto the device, and it kind of just resets and consumes the file and then starts running, just like it does CircuitPython. CircuitPython is my thought there just kind of went away, but I guess I'm going to say that CircuitPython is kind of similar, and in that once you save the file, it's consumed and then it starts running. You can save versions of these files in GitHub and what have you. You can save the UF2s. Sorry, I'm talking about UF2s. The UF2s that are created by MakeCode are savable in GitHub, and they are savable, and you can load them later. There's some kind of quirkiness to how they behave. Lately, I've been noticing they save out as a PNG file, as an image. It'll actually be a thumbnail of your project. And the thumbnail itself has the code embedded inside of it. So you kind of drag and drop the image thumbnail onto the MakeCode interface, and it will kind of unpack it, and then you'll have all of your commands there. So it's kind of strange. I'm not fully, don't have my hands fully around it. So it's not something I would suggest trying to utilize unless you kind of understand it better, but there is that. So the UF2s can be saved directly to device. CircuitPython comes in its own UF2. So you drag and drop a CircuitPython UF2 onto your device. Once it's recognized by your system, you have it plugged in on USB, and then it becomes a CircuitPython device, and it resets, and you'll see the CircuitPy file name, or excuse me, drive name, and you'll see some base CircuitPython files, as well as the main.py, or there's two other names for it, and I think, I can't remember the other two, that will start upon boot up, and main.py, and two other file names. I can't recall them right now. They're listed on the CircuitPython resources that Adafruit has. And so if any of those three files exist, main.py, index.py, and I don't know, maybe python.py, something like that. If any one of those files exist and have code in it, the machine will start, and vice versa. When that happens, you have to kind of, I think we just had a disconnect there. When that happens, you have to actually use an erase program to erase the SD-RAM on these, and that's also available on learn.adafruit.com. And let me just quickly check Discord here to make sure that we're not having problems. All right, looks like we're better. Okay, so that is about it. We talked about, so one more thing, sorry, the bootloader mode. These will only accept those UF2 files when you put them in bootloader mode. And a bootloader mode can be demonstrated by showing, if I hit the reset button on this device twice, I'm gonna try. Oh, and it's not plugged in, so I can't do that. Gotta make sure it has a USB plug in first. Okay, so if I just hit reset, it's running right now. Now there's a reset button right in the middle of this device. If I hit it twice, I'll get these green lights, and it's in bootloader mode. And you'll notice it doesn't say CircuitPython or anything like that anymore. It just says cplay boot. And this is when I can drag and drop. You may not be able to see that, but the device has responded. It's in the file explorer. It's showing me that it's no longer CircuitPy. The device is no longer called CircuitPy. It's called cplay boot, and it will now shows a UF2 in the root folder. This is the bootloader mode, and when these lights are green on these devices, that means you can load these UF2 files in and install them that way. MakeCode outputs UF2 files. CircuitPython itself is hosted on a UF2 file, or that's the right way to say it, is a UF2 file that you have to drag and drop on your device. To do that, you have to have your device in bootloader mode for that to work. All right, I think that is what I can put my brain to. We have another session starting in about 10 minutes, which is a teardown of my Thunder and Lightning kind of prop that I made for Halloween to be put behind miniatures, like miniature dollhouses. You put them behind windows, and it kind of will have thunder and lightning effect on a miniature scale for those types of miniature dollhouses. So that we'll be covering that. That'll be a Zoom session that starts in about 9 minutes at 5:30. And thanks for joining. Hopefully you found this somewhat helpful, at least informative, if nothing else. And I'm Curtis Soldano. This has been Hacker Lab that's hosted this. Thanks everybody for joining. Appreciate your time.